Imagine a reality where every choice you ever made, every path you didn't take, played out in a parallel universe. Picture countless versions of yourself, each living a life slightly or wildly different from your own. This mind-boggling concept is the essence of the multiverse. The idea that our universe, vast as it is, might be just one of many, perhaps even infinite universes coexisting alongside ours. Some universes might be strikingly similar to ours with familiar faces and places. Others could be unimaginably different, governed by exotic laws of physics and teeming with life forms beyond our wildest dreams. The multiverse challenges our understanding of reality, suggesting that our universe, with its unique history and properties, is just a tiny bubble in a much grander, more complex cosmic structure. The idea might seem like science fiction, but increasingly, physicists and cosmologists are taking the multiverse seriously, exploring its implications and searching for evidence of its existence. Join us as we delve into the fascinating and perplexing world of the multiverse, where the boundaries of reality are stretched, and the possibilities are truly endless. We often talk about the universe as if it's all there is. When we look up at the night sky, we see a vast expanse filled with stars, planets, and galaxies, stretching farther than our eyes or even our most powerful telescopes can see. For centuries, humanity has wondered about the true nature of this cosmic stage, whether it is infinite or if it has boundaries, and what, if anything, lies beyond. But what if our universe, vast and ancient as it is just one of many? What if everything we know, every star, every planet, every law of physics, is just a single chapter in a much larger story? This idea, once the realm of science fiction, is now a serious topic of scientific inquiry. This is the central question driving the study of the multiverse, a mind-bending concept suggesting the existence of multiple universes, each with its own distinct properties and history. The multiverse theory proposes that our universe is just one bubble in a vast cosmic sea, and that there could be countless other universes, each with its own unique story to tell. Think of the multiverse as a giant cosmic bubble bath. Our universe is just one bubble in this cosmic bath, alongside countless others, each representing a different universe with its own unique set of conditions. Some bubbles might be similar to ours, while others could be radically different, governed by unfamiliar rules and forces. These universes might be vastly different from ours, with different laws of physics, different fundamental constants, and perhaps even different forms of matter and energy. Imagine a universe where stars burn blue instead of yellow, or where planets are made of materials we can't even imagine. Some theories even suggest that these universes could exist in higher dimensions, beyond the 3 dimensions of space and one of time that we experience. In these higher dimensional realms, the very fabric of reality could be twisted and shaped in ways that defy our understanding. Imagine a universe where gravity is weaker, making everything float a little higher. In such a place, planets might never form, or stars might never ignite, leading to a cosmos that looks nothing like our own. Or a universe where the speed of light is slower, altering how stars shine and galaxies form. The very passage of time could feel different, and the dance of cosmic evolution would unfold at a pace we can barely imagine. In some universes, life might not exist at all because the conditions are too harsh, or the chemistry is too alien. These worlds could be silent, empty and dark, with no one to witness their beauty, while others could be teeming with exotic life forms beyond our wildest imaginations. Life in these universes might take forms we can't even begin to picture. Creatures made of crystal, clouds of intelligent gas, or beings that perceive reality in ways utterly foreign to us. The concept of the multiverse challenges us to think beyond the familiar and embrace the truly unknown. It invites us to question our place in the cosmos and to wonder whether our universe is unique, or just one of countless possibilities. It suggests that our understanding of reality is still evolving, and the universe, or rather the multiverse, may hold many more secrets than we ever imagined. As we continue to explore, we may one day discover that the story of existence is far richer and more complex than we ever dreamed. A story that stretches far beyond the boundaries of our own universe into the infinite possibilities of the multiverse. One of the most intriguing and mind-bending paths to the multiverse comes from the strange and counterintuitive world of quantum mechanics, a branch of physics that challenges our very understanding of reality itself. Quantum mechanics is the theory that governs the behavior of particles at the smallest imaginable scales, far smaller than atoms, in a realm where the rules of classical physics no longer apply. Here, particles can exist in multiple states at once, and their properties remain uncertain until they are measured. In the 1950s, physicist Hugh Everett III proposed a radical idea known as the many worlds interpretation. This mind-boggling concept suggests that every quantum measurement, every random event, causes reality to split into multiple branches. Imagine flipping a coin, not just as a simple game of chance but as a window into the very fabric of the universe. In our everyday world, we observe only one outcome, heads or tails. It seems straightforward, as if the universe simply picks one path and follows it. But according to the many worlds interpretation, both outcomes actually occur, each in a separate, branching universe. The universe doesn't choose, it splits, creating a new reality for every possible result. Instead of a single reality, the coin flip creates two distinct universes, one where the coin lands on heads, and another where it lands on tails. Both outcomes are equally real, but each exists in its own separate branch of the multiverse. This splitting of realities isn't limited to coin flips. It extends to every quantum event, every interaction between particles at the subatomic level. Each time a particle's state is determined, the universe branches, multiplying the number of possible realities. Every possibility, no matter how small or unlikely, gets played out in a parallel universe. The multiverse, according to this view, is unimaginably vast, containing every possible version of events that could ever happen. This means that countless versions of you are out there, each experiencing a different outcome of every quantum event in your life. In one universe, you might have chosen a different career, or met a different friend, or even taken a different route home. The implications are staggering. Every decision, every chance encounter, every roll of the dice could create a new universe, branching off from the one you know. The multiverse becomes a vast, ever-growing tree of possibilities, with each branch representing a different version of reality. While the many worlds interpretation is a radical and controversial idea, it offers a compelling solution to some of the deepest puzzles of quantum mechanics, such as why particles seem to be in multiple states at once until observed. Instead of collapsing into a single outcome, the wave function simply branches, with each branch representing a different reality. This elegant solution sidesteps the need for a mysterious observer and suggests that reality is far richer and more complex than we ever imagined. It's a stark reminder that the quantum world operates by rules very different from our everyday experience, rules that might just lead to a multiverse of staggering proportions, where every possibility is realized somewhere, in some universe, beyond the limits of our imagination. Imagine a pot of boiling water, bubbles constantly forming and disappearing. Now imagine that our entire universe is just one bubble in a vast cosmic soup, where countless other bubble universes are constantly popping in and out of existence. This is the essence of the Bubble Multiverse theory, a concept arising from the study of the universe's earliest moments. According to this theory, our universe began with a period of rapid expansion known as cosmic inflation. This inflationary period, however, didn't happen uniformly. Instead, it's thought that different regions of space inflated at different rates, creating separate bubble universes within a larger multiverse. These bubble universes can have different properties, different laws of physics, and even different numbers of dimensions. Our universe, in this view, is just one bubble among many in this vast, ever-expanding cosmic foam. The Bubble Multiverse theory is appealing because it provides a natural explanation for the uniformity of our observable universe, while also allowing for the possibility of other vastly different universes beyond our cosmic horizon. String theory, a leading contender for a theory of everything, offers another intriguing pathway to the multiverse. While quantum mechanics and general relativity have revolutionized our understanding of the universe, they remain fundamentally incompatible at the deepest levels. String theory steps in as a bold attempt to unify these two pillars of modern physics, suggesting that the universe is far more intricate than we ever imagined. At its core, string theory proposes that the fundamental building blocks of the universe are not point-like particles, as once thought, but unimaginably tiny, vibrating strings of energy. These strings are so small that, if an atom were the size of our solar system, a string would be the size of a tree. Their vibrations, frequencies, and modes of oscillation determine the properties of everything in the cosmos, from the tiniest quarks to the largest galaxies. Just like a violin string can produce different notes depending on how it vibrates, Different vibrations of these fundamental strings give rise to the different particles and forces we observe in nature. Each unique vibration corresponds to a different particle, such as an electron, photon, or even the elusive graviton, which is thought to mediate gravity. In this way, the entire symphony of the universe is composed by the harmonious interplay of these vibrating strings. One of the most bizarre and fascinating predictions of string theory is the existence of extra spatial dimensions beyond the familiar three, length, width, and height that we experience in our everyday lives. According to string theory, there could be as many as 10 or even 11 dimensions, each one intricately woven into the fabric of reality. These extra dimensions are thought to be curled up and hidden from view, much like a garden hose might appear one-dimensional from a distance, even though it has a two-dimensional surface. If you were a tiny ant crawling along the hose, you would experience both dimensions, but from far away, only one is visible. In a similar way, the extra dimensions in string theory are compactified, tightly wrapped up at scales far smaller than we can currently detect. According to some string theorists, these extra dimensions could be home to other universes hidden from our view, but potentially interacting with our own in subtle ways. These parallel universes might be separated from us by only the tiniest of distances in a higher dimensional space, yet remain forever out of reach, like ships passing in the night on different layers of reality. These hidden universes could have different laws of physics and even different numbers of dimensions, making them truly alien realms beyond our current comprehension. Imagine a universe where gravity is stronger, or where light behaves in ways we cannot even imagine. The possibilities are as endless as they are mysterious, challenging our very notions of what reality can be. String theory's multiverse is a realm of mind-boggling possibilities where the very fabric of space and time is woven into a complex tapestry of hidden dimensions and parallel universes. As we continue to explore these ideas, we may one day uncover evidence that our universe is just one thread in a vast cosmic web, an infinite expanse of realities, each with its own unique story to tell.